services also. Universitas 11 Maret or UNS is one of the top 10 university in Indonesia out of around 40,000 higher education institutions that we are having currently in Indonesia. Our university is relatively young compared to the other university, 44 years old. And for us, it is really a great opportunity to engage with you all the experts from around the world, from Japan, from Iran, on many other countries, and also from Indonesia. Our ideal also and our dream to be more productive and to contribute more in our country, Indonesia, in this field, in the field of space, aerospace, and navigational electronics. Therefore, I really hope that through this event, we can discuss many things, yeah. And hopefully, we can arrange and we can initiate a mutual partnership and collaboration in the near future. Ladies and gentlemen, we know this, our Indonesia also, we are a very wide country, and very large country, with around 280 million population. It's a big country. This technology on space and aerospace aerospace technology, we really need it, yeah, for our society. And we do hope also we can contribute not only for our country, but also for the world. Ladies and gentlemen, yesterday I met Professor Toshibu Mariyama from Japan, from Nagasaki University, who delivered a lecture to in front of my student and my lecturer. This is also a simple mutual cooperation that we can create in the near future. Therefore, for all of you, we always welcome you, and we open our door widely for all of you to create a mutual partnership, a mutual cooperation, and mutual connection with you all. Ladies and gentlemen, lastly, I wish you have a fantastic conference, and I hope everyone will be inspired and enlightened through this, the 18th International Conference on Space, Aerospace, Navigational Electronics, ICSANE 2023. And for those who come in person to this event, I hope you enjoy Surakarta or Solo and all the heritage city and beautiful city of Indonesia. Thank you very much. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Insinyur Solihin Asad MT, for the amazing speech.
And now for our next speech from SANE representative by Dr. Toshio Wakayama. To Dr. Toshio Wakayama, the stage is yours.
Thank you. I'm Toshio Wakayama from Mitsubishi Electric Corporate, and also the technical committee of Japanese Society, ICSANE. I'm very glad that many people join in ICSANE. And first, I'd like to thank all people who contribute to for this meeting, especially UNS people. Make such a wonderful, good, nice meeting room. And also, Hamuka-san has exchanged a lot, many emails with Japan side, and we can have this nice meeting. Thank you very much. And I also thank Professor Yosafato for his dedicated support of this conference. Mm. And one of the features of ICSANE is that we cover a wide range of electronics application, space system, aeronautic system, navigation, communication, and sensing, and other many radio technical application. So we can interact with people from several different fields, and this stimulates you, and you may refine your study or even create a new idea, I hope. And another point of point is IICE has a plan of a special issue on ICSANE 2023 in IIC English Journal. If you submit paper and be accepted to the special issue, your paper is also registered to IEEE Explorer, and your paper can be accepted, accessed to many people around the world. So please submit your paper to this special issue, I hope. So anyway, I hope all participants made use of this conference and also enjoy discussion in this conference. Thank you for your attention.
Thank you to Dr. Toshio Wakayama for the amazing speech.
All right, ladies and gentlemen of all participants and guests, those are for the amazing and wonderful speech for each representative. And now we can move on to the next agenda, which is a potong tumpeng ceremony.
For your information, the name tumpeng comes from an acronym in Japanese phrase, namely yen metu kudu mempeng, which means if you want to go out, you have to be serious about it. This means when you do something, you should do it with full dedication and effort.
The cone shape at the top of the tumpeng rice represents the concept of divinity. The peak of the tumpeng rice is a symbol of hope for a better life for humans. And the cutting of the tumpeng, starting from the top, aims to ensure that the event can achieve the best results. Then the pieces of the tumpeng rice are given to someone as a form of respect and affection.
So, without any further ado, to the representative of Universitas 11 Maret, Dr. Insinyur Solihid Asad MT, and to the representative SANE, Dr. Toshio, and Komit, the stage is yours.
To all participants, give round of applause. Thank you very much, Dr. Engineer Solihin Asan MT and Dr. Toshio Wakayama for the taking of Potong Tumpeng ceremony.
And to all participants, please join us in front of because we have to do photo session. Okay, please face the screen.
For the top row participant, please stand up for the photo session too. Gather around to the middle, to everyone on top too, for the right side and the left side. Gather around everyone to the middle section. For the right side, please go to the, yeah, yes. It's still from like here. I think sampai dari dokter udah banget ya. Ya, bagian mungkin ada yang di depan. Yeah. To the right side, please go to the middle, maybe sit. I'm sorry.
Okay, are the cameras ready? Okay, give your best smile and I will count from 3, 2, 1 and smile. Okay, once again, I will count from 3, 2, 1 and smile.
All right. Thank you for your participation. Ladies and gentlemen, you may be seated back and we'll continue our agenda.
Ladies and gentlemen, now we are entering the plenary talk. And the plenary talk will be divided to 3 sessions, and each session will be brought by one keynote speaker and a moderator.
All right. For our first session, will be brought by Dr. Robertus Heru Trihajanto as the Director of Organisasi Riset Penerbangan dan Antariksa or ORPA from BRIN.
And for the second keynote speaker, there is a Professor Josafa Tetuko Sri Sumantyo from International Research and Education Collaboration on Microwave Remote Sensing from Chiba University.
And the third keynote speaker, Dr. Pekka Hasemfat Kiabani from International Capacity Building on Remote Sensing for Asia and Africa at Remote Sensing Technology Center of Japan.
And will be followed by lunch break and parallel session.
Without further ado, let's start our first plenary session, which will be brought by Dr. Robertus Heru Trihajanto as Director of ORPA BRIN. As the moderator for this session is Dr. Miftahul Anwar. To Dr. Miftahul Anwar, the stage and the session is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning to all of the speaker and participants. Honorable Dean of Engineering Faculty, Universitas 11 Maret, Dr. Insinyur Solin Asad, representative of SANE, Prof. Toshio Wakayama from Mitsubishi Electric Japan, our invited speaker, distinguished speaker, distinguished participants, ladies and gentlemen. My name is Miftahul Anwar. You can call me Anwar, usually. It gives me a great pleasure to be the moderator of the plenary talk of 18th International Conference on Space, Aeronautical and Navigational Electric ICSANE 2023. Welcome in Solo, the spirit of Java. Since many of you, participants and speakers come from Japan, I would like to say Soloe Yokoso. Sorry if I'm wrong. We hope that from this meeting, we'll get many experience, especially from the invited speaker and all of the participants, in terms of culture, foods, and many things in Solo. This morning, we have 3 speakers who will be our invited talk. First is Dr. Robertus Heru Triharjanto, to present the material of microsatellite research at National Research and Innovation Agency, BRIN. And the second will be Prof. Josaphat Kosri Sumantio, to present the material of International Research and Education Collaboration on Microwave Remote Sensing. And lastly, will be presented by Dr. Pegah Haspat Fiebani. Sorry, some mistaken. To present the material of international capacity building on remote sensing for Asia and Africa. Before we begin the presentation, let me tell you how the plenary talk will run. Each speaker will present the material for about 30 minutes. Following that, we will have a question and answer session for approximately 15 minutes. For participants joining the Zoom meeting, you can type the question in a chat room or raise your hand and open the microphone for the question. For the participant in this room, you can directly raise your hand for the question. And after that, we'll have a 10-minute break, each after the speaker and the presentation. We'll have a 10-minute break. Firstly, first 10 minutes, and then after the break, the session will continue with another 30-minute presentation by the next speaker and so on. Ladies and gentlemen, I would invite our first speaker, Dr. Robertus Heru Triharjanto. Before the presentation, I would like to read a brief CV of our speaker. Dr. Robertus Heru Triharjanto, he received bachelor degree in aerospace engineering from North Carolina State University, USA, and master degree in aerospace engineering from Texas A&M University, USA, and PhD in aerospace engineering from Institute of Technology, Bandung, Indonesia. He started his service at National Institute of Aeronautics and Space (LAPAN) in 1998, served as design or flight test engineer for LAPAN, as well as air safety investigator at National Transportation Safety Committee, MOT, until 2003. He then became lead engineering for Indonesian first microsatellite development until 2008. He also served as satellite design engineer at Satellite Technology Center until 2018. During that time, LAPAN developed and launched its second and third satellite. He also served as a director of Center for Aerospace Policy Study, LAPAN, until 2021. Now he's Acting Director of Research and Innovation Partnership, National Research and Innovation Agency, BRIN, until March 2022. Then finally, he served as Head of Research Organization for Aeronautical Space, BRIN. Ladies and gentlemen, without any further ado, now allow me to welcome Dr. Robertus Heru Tiharjanto.
Good morning, ladies
Please.
and gentlemen. Allow me so that I can see the screen. Could you please bring up the presentation files? My presentation this morning is titled Microsatellite Research at National Research and Innovation Agencies. Why microsatellite is the one that we choose? It's because it's the launch is much cheaper. If you have a satellite less than 150 kilograms, you can launch it along with a bigger satellite. So there is a passenger that already pay for the entire rockets. So what usually the auxiliary passenger or second passenger have to pay is a very fractional cost. And that is what preferable for research, especially in developing country like Indonesia. Next one, please. Okay, this one. So allow me to start with a system engineering chart for a satellite. We started our research in 2008 with LAPAN-A1 is the one that is developed by TU Berlin. At the time, we are not leading the design and the development because we are still learning phase. But the one we actually built ourselves is starting in 2008, 2009 actually. We did LAPAN-A2, A3 that has been launched. This one is 2015, 2016, and LAPAN-A4 that will be launched next year, and LAPAN-A5, which is until now still in the design phase. So in satellite system, we usually talk about two things, payload and the bus. Payload is the one that will carry the mission, and bus is the one that will support the mission. The satellite bus is typically has three purposes. First, it's giving power to the electronic components of the satellite. So the power module will consist of battery, and of course there are nothing else to charge the battery but the sun in the space. So you have to have a solar panel, and of course you have a battery control or power control unit. So the one that I put the color is the subsystem or the component that we have been building in BRIN, in LAPAN previously, since LAPAN-A2 until now the conception of LAPAN-A5. So we have been building the attitude control module, star sensor we have built, sun sensor, earth sensor, reaction wheel, and the control electronics for the attitude control. Of course, everybody that built a satellite, they will have to design and build the structure and the mechanical system of it. And okay, so the yellow one is the one we already built and is already in flight. The green one is the one that we are starting to build. For the payload, for example, payload side, there are three types of payload that we have been flowing in LAPAN-A2, until LAPAN-A4. First is the imager type. Imager type consists of data handling, and of course, optical imager, you will have to have lenses and CCD. I put plus on the CCD because it's, of course, you have built the camera electronics. It's usually very custom made, so we'll have to build yourself. Of course, you don't have to build CCD. You can buy CCD, you can buy lens, but the electronic you will have to build, the data handling you will have to build. We are starting building up this data handling and camera electronics since 8A3 and 8A4. In addition to the imager payload, we also have flown telecommunication payload. In 8A2, we have flown AIS, which is a ship tracking. PRS, which is a SMS with in amateur radio frequencies and voice repeater system. Thank you. And the AIS is the one that we will start building in 8A5. In the future, we will fly the ADS-B, which is a ship tracking, and of course, IoT, starting with in 8A4. For scientific mission, we have flown a magnetometer. Of course, this is this component we do not build. We bought it from available manufacturer. And the most complicated part of a satellite bus development that we will have to do. The one I put in green is partially developed. For the TTC and payload transmitter, what we built is the antenna side. Of course, sources, available sources. Next one, please. Okay. So to have less confusion on the terms, I would like to mention why there is a term of BRIN and term of LAPAN. It is because there is an organizational changes. Before 2021, we were called National Institute for Aeronautics and Space, or LAPAN. And starting 2022, we are integrated to BRIN, or National Research and Innovation Agencies, and our name become Research Organization for Aeronautics and Space. So, so I will start with the 8A2. When we built the satellite, in addition to design, if you, for example, a beginner and bought most of the components, what you will have to do is assembly and, of course, performing the operation. And for the satellite operation research, we started with 8A2. One of them is the post-disaster communication support. Here, we are using the voice repeater, which is in VHF and UHF, uplink downlink, and the IPRS. There are two, for example, I put the two publication here showing the result of the how
Recording in progress.
1000 millimeter lenses. This is typical camera lenses. You get it from the store. What we built here is the focusing mechanism, because the typical camera that was built for terrestrial application, they don't care about the thermal expansion because you can always adjust it. But if you have a space camera, typically you build the camera not with the metallic tubes. The lens is not with a metallic tube, but with a composite. So you don't have a thermal expansion. If you have a thermal expansion, focus will go, and then you have to build a focusing mechanism. That is the one that we built as a part of the mechanical system and part of the damper as well, to ensure that the fragile optics survive during the launch. And we perform, because the satellite is very agile. It has a three-axis reaction wheel control. There are some cases, for example, during Palu earthquake and Lombok earthquake, that we make the satellite point to the disaster area a day after the disaster, and we managed to capture some image to help the disaster relief effort. And so that proof the structure and the mechanics that we have built, and also prove the operation system that was designed for the 8A2. Next one, please. On the next satellite, the 8A3, we are no longer bringing RGB camera, but we bring multispectral imagers. This is because BRIN, our 8 previously, has been serving the nation for remote sensing services for almost 20 years by now. So the satellite that we built is, of course, a remote sensing satellite, because we already have the off-takers for the image. And this is what we did with 8A2. It has a 20-meter resolution 4-band imagers, which is Landsat 1, 2, 3, 4 band. And because now you have a line imager, you did not treat it in the attitude side. You have to treat it differently with compare when you have an RGB. With the RGB matrix camera, you can accommodate jitter, but not with the line imager. With the line scanner, for example, if you see the line paper scanner, you will have to have a very stable attitude. And therefore, we are using different strategy for the attitude control. We are not using 3-axis stabilization anymore, but we are using inertial pointing stabilization. So angular momentum management, we call it. So with this inertial pointing, which is an open loop system, not including gyro in the loop, we can achieve a very stable scanning, capable enough for the in our calculation until 5-meter resolution imager. And this is what we had in 8A3. The next question would be, can it take an image of nadir? Typical satellite remote sensing, the big one, will have a nadir pointing only. But if we do that, we will only have 17 revisit in a year of the same place. So we try to do, meanwhile, Indonesia has a lot of clouds. So 17 revisit a year, it's not very good. So we try to make a off-nadir maneuver while scanning. And for example, one of the publication was done by Ms. Kamsah and others. When they tested the satellite perform, for example, this is where the satellite passes, and this is the target. They are scanning it 65 kilometers off the satellite ground track center. Even more, on the second experiment, they are doing it 350 kilometers off track. So, with this maximum 34 degrees of nadir angle. And that we can make an image that still can be can perform geometric correction. So the image quality is still good, and doing so with a 34 degree of nadir capacity, 883 can perform 71 revisit per year. And this is one of the example when we make the national coverage within a few months of the operations. Until 2023, 883 has produced 538 million kilometers square of image. In 883, some of the components we built ourselves, which is the reaction wheel, control electronics, the wheel control electronics, and the star sensors. This is the one that I mentioned in the system schematic earlier. And next one. Okay, this is the one that we will launch October of next year, 884. 884, the development in 884, component development in 884 is imagers. We are started to build our own imagers with the resolution of 5 meters. These big lenses are our imagers, 5 meter resolution imagers. The one with the small lenses, this is the camera we bought from UK. It will have about 20 meter resolution with 200 kilometers watt. So it's for the large watt image. The antenna, we don't use the same antenna as 883, but we built different kind of antenna like this. And is one of the component that we built. So in addition to carry the in-house component like the attitude control, we now also carry our own imagers and some part of the antennas. So the mission are this, sorry, 16, not 20, 200 kilometers watt, and 5 meter resolution. This is the one that we built ourselves. We also bring infrared camera, the one that we develop ourselves and the one from Hokkaido University. And of course, we bring also another AIS for the ship tracking. There are, I point out there are about 4 prominent component development papers from 884. Among other is the payload data handling that we built from with the FPGA. And this satellite will be launched, will become part of a BRIN constellation satellite, which will be in a polar orbit. We will also build the constellation of IoT satellite, which is the, we will call it A5 right now, in 10 satellite in 0 degree or in equatorial orbit. And I will speak about it on the next slide, please. Okay. This is the concept of the LEO constellation for narrowband communication satellite, which is about 10 satellites. It will perform ship tracking based on our experience in 882 and 83, aircraft trackings, IoT, and the one that we start, the component that we develop in this satellite is we starting to develop our own onboard computer, our own power subsystem. So we now only buy battery cells and solar cells. We develop the panel, we develop the battery pack, and of course, a power management system. And also we built the AIS and the IoT payload. I forget to put the IoT payload paper here, but this is the paper about the AIS based on SDR, and the this is about the power module, power management module. So Another IoT that we develop is data collecting platform in VHF and UHF. We expect to be able to collect data from all disaster sensor, tsunami sensor, earthquake sensor, volcano sensor that usually are placed in the remote areas where there are no 2G even, 4G, or 3G even. So it will use the SMS type via satellite to collect the data, and that will reduce costs compared to the what system currently is happen today using a geostationary L-band Inmarsat class satellite. So next one. I'm sorry that some part of this are still not in English, but this is the program of BRIN. We call it talent management. It's from the Deputy for Science and Technology Human Resources. So this deputy make a talent management program, which means that BRIN is available for collaborating with the university, starting with the undergraduate student. For undergraduate student performing final assignment, we offer to pay 1 semester tuition if the final assignment is done in BRIN with the co-advisor from BRIN. And of course, other than that, we could hire a research assistant, RA. If any of you are a graduate student, and we will provide a scholarship, BRIN will provide scholarship in a DBR scheme, degree by research. So your research will be done in BRIN. You will become a research assistant there. We will collaborate with university on advising you to get a degree, and same with the doctoral student and for the dissertation. So we will hire research assistants, and also BRIN is open for postdoctoral. If you just finish your doctoral degree and you are wish to have a postdoctoral, we are offering, and some of you, this is for the Indonesian as well as for international candidate, and of course visiting scholar is also in our program. Next one, please. So those are the program from BRIN, starting from research assistants for graduate student, a master and PhD, undergraduate student for the final assignment or final year, and postdoctoral and visiting researchers. Next one. This is the one that we are currently calling in Research Center for Satellite Technology. We are opening for a postdoctoral degree for the satellite sensor topics, and this it is extended right now. So we will repost this announcement. We will extend for another 6 months for the registration, and of course we will extend the research time into next year. The second opening is for the satellite operation research. So this one is the topic is calibration of onboard computation of satellite payload data. For the operation, the research topic is satellite data processing and utilization. And the third one, next one, is the for communication system on a satellite. So the research topic is developing the RF payload as well as antenna development. So again, the opening is this extended for the next semester, and also the period is also being delayed starting the next year. So those are the program that we have in BRIN, and that would conclude my presentation today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. God bless us all.
Thank you very much, Dr. Heru, for giving such informative and comprehensive presentation for the first part. Ladies and gentlemen, now we come to the QA or discussion session. Maybe for the participant, again, join in the Zoom, you can type the question in the chat room or raise your hand. And for participant in this room, you can raise directly your hand. Yeah. Okay, we're going to select 3 questions. Any question in this room? Any question? Or maybe the second floor, my student. Do you have any question? No? Okay, please, sir. Please offer the microphone.
Thank you very much, Mr. Moderator. Prof. Heru, I want to ask you about your planning in the future to develop the microsatellite. Yeah, it's very good idea. But I want to know what kind of your orbit of your satellite. This is around the world or only in Indonesian area? Yeah, thank you.
Thank you very much for the question. So 882 is take the ride with a scientific satellite of India. The satellite at the time was the Indian satellite mission is to scan cosmic radiation. It's for scanning the stars. So the orbit at the time was the orbit for 882 is 6-degree inclination from the equator. So 882, that is why it's perfect for a telecommunication mission because it passes Indonesia 14 times a day. Until now, the Indonesian amateur radio community is still using it daily for their communication needs, as well as some university are having a practice of tracking satellite using it. And so apart from experimenting with the images. So 883 is launched together with an Indian mapping satellite called Cartosat. So it has initially it has a sun synchronous orbit, inclination of 97 degrees from the equator. However, 883 do not have an orbit control. So I should say in the systematic system engineering box, in addition to attitude control, there is an orbit control where the propulsion is. The propulsion usually pairs with the right now the orbit detection is people are using GNSS, right? Using navigation satellite system. So in 884, in 883, I'm sorry, because it doesn't have an orbit control, the orbit drift. Every year it become morning and more morning than. So initially it is 9:30 a.m. equatorial crossing. Now it is 6:30 equatorial crossing. So it's already too dark to make an image this year. In 884, we will have an orbit control. We will have a propulsion system. So every year we could guarantee that the image is taken using the same sun angle or illumination, just like any other professional remote sensing satellite. So it would be the improvement from our previous satellite.
Is it okay? Okay, thank you very much. Then any other question? Yeah. From this room or from Zoom chat maybe, or directly? Okay, we have, okay, please.
Thank you very much for your presentation. So you introduce a small satellite, and the sensor is maybe it's a camera and IR sensor you introduced. Yeah. So recently, small satellite with synthetic aperture radar is very attractive. So then, do you have Indonesia have a plan to launch this type of satellite with synthetic aperture radar? Yeah.
Yes, we do. Actually, we were making some design with Professor Josapat. I think we are starting 2014 until 2017 when Chiba University Center for Environmental Remote Sensing is developing a SAR payload. We are designing the satellite bus for it. I think it's published in 2017 or 18 ICARES. We put some preliminary design of how to fit the synthetic aperture radar developed by Chiba University in microsatellite bus. However, at the moment, we have not yet able to realize that because there are some funding issues in developing the space hardware. The engineering model is already there with Professor Josapat Development Laboratory, but we need to make the space hardware and also in parallel develop the bus. So we do have some concept about it, but we are still looking for more resources to be able to develop these dreams. Thank you very much.
Thank you very much.
Okay, thank you very much. We have one question from the chat. Yeah, I will read it. It is interesting that payload of A4 and A5 has AIS and ADS-B. They must be efficient for collecting ships and aircraft data in island countries like Indonesia. My question is, do you have specific applications such as providing data to university or marine or aviation bureau from traffic analysis?
Thank you. The AIS payload for 882 currently is off after 12 years of operation. So, but previously, the 882 AIS could it scan the Earth, and it can take data from a latitude of 20 degree north to 20 degree south, about 2 million ships messages per day. About 150,000 ships messages are from Indonesia territory because it's passing equatorial country 14 times a day. And we, at the time, we until 3 years ago, we supply the data to our maritime authorities. We call Bakamla, the Maritime Security Agencies, and the Ministry of Fisheries and Ocean. And they develop some application, for example, to find some illegal fishings, to illegal transshipment when they look at the signature of this AIS, the ship traveling. For example, it is not a fishing vessel, but it keep going back and forth at the same line. And that usually indicates that they are waiting for a fishing vessel to come and smuggle their fish. They didn't want to go to the port and pay tax royalty for the fishing, but they have this mothership to carry their fish outside the Indonesian territory directly. They call transshipments. There are some cases that we have caught some illegal activities. One of the notable cases I remember is there is a cruise vessel that make damage in the coral reef of Raja Ampat. And we are able to track the ships. We are able to provide the evidence to the court for the Indonesian government to sue the ships for the damages. And there are some other criminal cases that has been solved using our AIS data at the time.
Okay, thank you very much. Any other question? Yeah. Okay, please. First.
Yes. Hi, Professor Robertus. My name is Noor from RMIT University, Australia. So since my background is bushfire remote sensing, I'm more interested in the imager side of the microsatellite you guys are developing, especially for LAPAN 3A. So if I heard correctly, there will be like 71 deficit time per year for each place for polar orbiting satellite, which is pretty good. But my question is, how about the quality of the image? Because the common issue about the microsat and CubeSat is the image availability and the quality. Thank you.
Thank you. So it is launched in 2015 and we are finished in orbit test and calibration because it is the first time for us, almost a year. So starting 2017 is when we are able to send these images for band images to the remote sensing division to complement the Landsat data that they take every day. So every day they receive data from Landsat, but the requirement, for example, from the Ministry of Agriculture is to have update of paddy rice status every 2 weeks. So and while this Landsat scan, sometimes they have cloud. So 883 during 2017 until 2019 were able to complement some images. When it is cloudy in Landsat, we could stitch 883 images there so for them to be able to get a better estimation of the rice status, which is in Indonesia is very important parameter for the Ministry of Agriculture. After 2019, because of the orbit keeping, it become, I think after 2020, it started to become 1 hour later, and we stopped performing dispatching because the radiometric calibration are becoming more difficult.
Thank you.
Can I ask another question?
Okay.
Just please, quick one. So regarding the LAPAN 3A, which IR band is planned for the next upcoming satellite? Which micron, which electromagnetic spectrum that you choose for your IR band? Because I haven't heard of like the actual, like is it like around 4 micron for fire, or like do you choose another infrared band?
In 883, we do have infrared camera, but actually it is not intended to for initially when it is installed, it is not intended as an infrared images. At the time it was installed as a Earth sensor or horizon sensor. It's one of the attitude attitude sensors when you able to detect the horizon of the Earth. But we saw that it is promising. The band, the camera band that we actually buy was able to identify large gradient like a hotspot from forest fire or volcano only. I forget the micron of the band, but I remember it is the typical that people can see hotspot and volcano, forest fire or volcano. In 8A4, there are um, 3 infrared cameras we bring. One from Hokkaido, one two of them we carried ourselves, and that's our 2 band. I will have to check which, but one of them is on the thermal side, the same thing with 8A3, where it could detect big gradient of temperature changes like in volcano and in a forest fire. The one from Hokkaido is have more precise filter, and it can search for water, for example. Actually calculate the lake of the content somewhere.
Okay, thank you very much for the question. One last question, please, because our time limited. Okay. One last question.
Yes. Thank you, Mr. Moderator. My name is Faris Adirawan from Gadjah Mada University. Good morning, Mr. Heru. Maybe my question has already been answered. I just want to know why choosing a satellite from India, from not other one fellows ASEAN country, maybe Vietnam, and possibility of UN research by ASEAN country. Thank you, Mr. Heru.
Thank you for the question. So yes, we launched 3 satellites from India, and we'll be launching the 4th one again from India. Why? Because we have a strategic collaboration with them since 1995, if I'm right, 1997. That India is having their tracking station in Indonesian territory in Biak Island. So because of that, if we go to them, we always get a discounted price, large discount, which they say that I cannot tell it anybody else is about it, but it's a big discount. That is the only reason we go there. So of course we are aware there are other launch opportunities, but the money is the reason that we go to India.
Okay, thank you very much. Due to limited time, we need to end our discussion session. Thank you very much, Dr. Robertus Heru Triharjanto.
Thank you. I'm still here until evening. If you have any more
if you have any question, yeah, you can give any other question outside. Yeah. Okay, and we are going to have a short coffee break for 10 minutes. Yeah, please return to this room at 10:30, and we'll continue with the second part of the invited talk. Thank you very much. The coffee break will be in the back of this room, please.
Recording stopped.
Before we move on to the next material station, there will be a speech from Professor Anusi Kezina about introduction of IEI. Professor Atsushi, the stage is yours.
Good morning, everyone. I have an important information about the academic activity in Japan. So I'd like to introduce that for a few minutes. Firstly, I'd like to say thanks to ICSANE 2023 committee staff and the UNS professor and other staff for hosting ICSANE 2023 meetings. And my name is Atsushi. I'm Atsushi Kezuka from Japan. And important information is, as you know, IEIC transaction on communication, special section on space, aeronautical and navigation, electronics, in conjunction with main topics of ICSANE 2023. Next slide, please. Submission deadline is May 8, 2024, and all of the paper, accepted paper of these issues will be published in advance on the website by using the final review manuscript as it is. Which is
Recording in
called
progress.
advanced publication. Official publication is April 1st, 2025. Next slide, please. Topics of this special section of transaction is same as ICSANE 2023. But the papers which are slightly outside of the scope is also acceptable. Next slide, please. And note that this transaction special section of ICSANE 2023 opened to all readers through IEEE Explorer, IEEE Explorer. Next slide, please. If you have any question, please ask to Professor Moriyama, Chief Editor, and me, Atsushi Kezuka, Editor. Please modify ICSANE proceedings and submit it to IIC transaction. That's all. Thank you very much.
Thank you to Professor Atsushi Kezuka. And now we move on to next material session from keynote speaker 2. There is a Professor Josaphat Tetuko Sri Sumantyo from International Research and Education Collaboration on Microwave Remote Sensing from Chiba University.
Okay, without further ado, let's start our second plenary session, which will be brought by Professor Josaphat Tetuko Sri Sumatyo and the moderator itself, Dr. Miftahul Anwar. To Dr. Miftahul Anwar, the stage and the session is yours.
Thank you very much, Master of Ceremony. Yeah. Today, we would like to continue our session. We are going to listen to the second part of the presentation to Prof. Josaphat Totoko Sri Sumantio. You are invited to come to the stage, please. Okay, before we start the presentation, I would like to read a brief CV of our speaker. Yeah. Professor Josaphat Totoko Sri Sumantio, PhD, he received bachelor and magister degree in computer and electrical engineering at Kanazawa University, yeah, in 1995 and 1987, and PhD in artificial system science, yeah, applied radio wave and radar system, satellite on board synthetic aperture radar from the Graduate School of Science and Technology, Chiba University, and currently he is a full professor at the Center for Environmental Remote Sensing, Chiba University, Japan. And as a visiting lecturer at various university, he also one of the patent holder for microchip microstrip antenna, which can be used to communicate directly with satellite. He is also inventor of circularly polarized synthetic aperture for unmanned aircraft and small satellite, as well as three-dimensional weather forecasting radar. He's also a lecturer and researcher at Department of Electrical Engineering, Faculty of Engineering, Universitas 11 Maret. Yeah. To Prof. Jos, please.
Maybe may I stand in front of you? Yeah. Okay. Good morning, everybody. Hi. Thank you very much for the invitation. Yes, I want to start my special talk today. Yeah. First is I want to thanks to all of the committee members that realized this symposium that we prepare. I think it's about one year. Yeah, to prepare this symposium. Yes, especially to Dr. Professor Solihin as the dean and also the head of department, Pak Ferry, and also Pak Anwar. Yes, another member, especially Pak Hamka, Pak Subuh, and so on. Yeah, and also from the ICSANE side. Yes, Pak Kayamasang. Yes, and also the Professor Moriyama. Yes, Kezkasang. Yes, and also another visitor. Yeah. Okay. I want to start. My talk is 40 minutes. 30 minutes. Oh, okay. Yeah, no problem. Yeah. Okay, I will talk fast. Yeah. Okay. How to use this? Okay. Yes. My name is Josaphat Totoko Sri Sumantio, the professor in Center for Environmental Remote Sensing, Chiba University, and also in this university, the Department of Electrical Engineering. Yeah. Today I want to talk, yes, related the international research and education collaboration on microwave remote sensing. This is what we already done in my laboratory. My laboratory is JMRSL, Josaphat Microwave Remote Sensing Laboratory, or just please call just Josaphat Laboratory. We developed several types of the synthetic aperture radar on the microwave remote sensor. Yes, and also I developed this one is large-scale unmanned aerial vehicle with the wingspan 6.6 meter and the length is 4.8 meter. And yes, last month, yes, I attended the interview with from the GST. I hope if we can pass this proposal, I plan to develop 10 large-scale UAV with 5 for the synthetic aperture radar and another 5 is for the dropping side. And okay, and the other is for CN235 aircraft. And you can read my new book that published last April. You can find here is about how to design the synthetic aperture radar and the hardware itself, and how to make the ground test, and also in laboratory test, flight test, and the application. All is in here, is including the code. Yes, it's all is very complete. And the other one is I also developed on the Boeing 737, the X band. Yeah, this one is C band, and here's the L band, and also the microsatellite, like mentioned by Dr. Robertus. Yes, in last presentation. Okay, next. Sorry, it is not work. Yeah. Okay, the content of my talk today, yes, background and objective, and then the concept on the CPSAR. CPSAR in the circularly polarized synthetic aperture radar that it is developed in my laboratory, and the system itself, mission and roadmap, flight mission, image processing, and the microsatellite CPSAR application. And okay, today is about the how to collaborate. Yes, about the how to realize the technology of the microwave sensor. Okay, next. Yeah. Okay, it is in the background of my research. Actually, my laboratory developed the synthetic aperture radar with multi-band and multi-platform. Yes, it is for the disaster and environmental monitoring. We work together with many institutions, yes, including this university. I supervise maybe around more than 10, yes, until today, on the student and also researcher. Now is two researcher from here, Pak Subuh and Pak Hamka, also studying in my laboratory from the PhD. And next is another Pak Tendra will also enroll to my laboratory. And we also develop some what is program. Yes, I will show you about the double degree program and so on. Yeah, from the detail is later. Yes, I want to also explain about the education program that we created in Chiba University. And the objective is, yes, our laboratory collaborate with domestic and international institutions to develop the multi-band synthetic aperture radar on board UAV, yes, already established, and the aircraft already established. Now we work for the high altitude platform or HAPS, yet when the altitude 15 until 25 kilometer. In this case, we work together with the SoftBank, yes, of the big company in Japan, yes, to realize the HAPS synthetic aperture radar. And the other one is the microsatellite, like shown here. And okay, today is I want to show some part of our research is related the airborne and microsatellite SAR mission. It is some of the picture our radar system that in this case, yes, we work together with the Japan radio company or GRC, and we already delivered to the GRC. And this one is from the Chiba University and also Taiwan Aerospace Agency. Before in the NSPO, and today is to be in the TASA. And this one is C-band. Yes, it is for our laboratory. And L-band is for our laboratory, and we also deliver under the SATREP program, JICA and GST program. It is in the Japanese government program that we deliver the L-band from the Malaysian government. Okay, and the L-band itself, yeah, we developed in my laboratory, and we already contribute for some company in Japan, like the QBS, and also sensitive is also X-band. We also deliver for them. And the first design is I designed for the Professor Saito Hirobumi, yes, and then he delivered from the sensitive, and also the QPS is directly we design for them. Okay, next. Oh. Yeah, it is my patents, yes, related the circularly polarized synthetic aperture radar. And from the details, you can read my paper in IEEE Star. Yes, here is the, when the title is the airborne circularly polarized synthetic aperture. A little bit, detail, yes. And then from the detail, please read my book. And the first image of the CPSAR is we made the Hinotori, yes, situ. Hinotori is in Japanese is the meaning is the Firebird. Yes, Firebird C is C-band. Yeah, we also have the Hinotori X1, X2. Yeah, and then from the concept is we transmit the right-handed or left-handed, and then scattered is left-handed and right-handed, and then we process and we can get the full polarimetric image, and you can use for more detailed application. Okay, right now the CPSAR is already proved by the CAS, yes, Chinese Academy of Science. Yes, last time I read the one paper that they prove our invention, and some of the reference is from our laboratory, and it's very good result, yeah, compared to the linear polarization. More detail and more precise, and the scattering is more better. Yeah. Okay. Compared to the optic sensor on the camera is camera is will affected by the cloud, but in our case is it's very clear. I think it's, some of you is not yet know about the synthetic aperture radar. Synthetic aperture radar we use the microwave and can penetrate the cloud. Has, if I have time, I will show you later. Yeah. Okay. Next. And I want to fly at Asia, and I want to fly at Papua, yeah, and also Morotai, yeah. But unfortunately, in the COVID, and then we pending. I hope next, yeah. Now we still arrange, and we want to fly. Once flight is, we can operate for the 6 months. It's very long, yeah. And then you can get landing again, and you can maintain, yeah, and manage again and upgrading, and then you can fly again. As compared to the the airborne UAV on the microsatellite, is I think it's more efficient. Yeah. On the cost performance is I think better using the hubs. Yeah. And you can get now we also develop the video synthetic aperture radar. You can get every second is 24 images. Yes, it is. I think it's very good for the future synthetic aperture radar. Okay, I hope yes I can develop all of this, can complete is before my retirement in 2035. Yeah. Okay. Next. Yes, it is the roadmap in my laboratory. I hope some of you, if you want to enroll our laboratory, and we have some collaboration with many university in Japan. Yeah, and also yesterday, as Professor Moriyama also gave talk to you. Yeah, I hope some of you can enroll to Professor Moriyama laboratory too. Yeah, I think it's you can find many excellent professor. Yes, in this ICSANE. Please, actively to contact to all of them. Yeah. And then you can enroll and continue your, master and doctor course. Yeah. This is the roadmap in my laboratory, and we already developed some of the synthetic aperture radar, and now we continue from the hubs. Yeah. And also from this GX2. Yeah. Now we develop the GX2D. D is the dropping. Yes, to drop. We bring here the container, two container when the payload is totally 25 kilogram, and also the GX2S, S in the sensor. We the payload itself is here in the synthetic aperture radar, and some of another remote sensor. Yeah. Okay. Next. Okay, from the collaboration, yes, we work together with many people. Yes, I just pick up here. Today the candidate of Indonesian president is also my friend. Yes, Pak Prabowo. Yeah, sometimes yes, if he come to Tokyo, is also invite me, and also Pak Luhut Panjaitan. It is my friend since he was the Kodiklat in in Bandung. Yeah. And also Pak Hadi. Pak Hadi is, he established the SMA Pradita Dirgantara, and I also work for him. Yeah, and now it's not just the university. We also created some of the high school in Indonesia. Yeah, I hope some of you also can work together with us. Yeah, and my family also have some foundation that support from the scholarship for the Indonesian student. I hope we can, enrich our knowledge. Yes, especially in the remote sensing field. Yeah. Okay, this is some article in Japanese that related my, invention, because we created the synthetic aperture radar. Especially, I started to develop the synthetic aperture radar since 1993. Yeah, it's very, before the JETS one. Yeah, we already started the radar. Yes, and we gradually, and then we established and realized the synthetic aperture radar. And okay, this is some of the article in Japan related my invention, including the antenna and the system itself, including the transparent antenna is also developed and used by some of the car industry in Japan. Yeah. Okay. Of course, in Indonesia, we also have many articles, and some of you maybe sometimes see me in Indonesian TV. Yeah. Okay. Next. Oh yes. Please find in the Kick Andy Anak Kolong or Kick Andy Yosafat. You can find about the history of myself since I'm born in here and I grew up in Solo. Yeah. Okay, the collaboration that we already established, I just want to talk about the double degree program. We have the double degree program with the 7 university in Indonesia. Yeah, close here is the Gajah Mada University, and I hope we can start with the 11 Maret University in soon. Yeah, for master program. Yeah, you can study here 1 year and study in Chiba University for 1 year for the master. And another is from the doctor course. I think it's here, Pak Oka. Yeah, Pak Oka is also our student from the double G program with the Udayana University at Bali Island. Yeah, he stay in Chiba University for 1 year and 2 years at Udayana University, and you can get 2 certificate from the doctor if you pass the examination. Yeah, you can get from the Udayana and also from Chiba University. Okay, it is very important that we need to develop something with the domestic and international institution. For the domestic, as we work together with many university in Japan, yes, including JAXA. Yes, we also contributed from the microsatellites. And also for the Kanazawa University, it is my former university at Ishikawa Prefecture. Yeah. And the international collaborator, we work together with many institutions. Yes, Indonesia, Malaysia, Korea. We work together with the Korean Aerospace Agency for the KPLO, yeah, Korean Pathfinder Lunar Observer for the moon observation, and Aju University. And Taiwan is NSPO, no, it's to be TASA, yeah. And NCU and China is we work together before even the Fudan, yeah, University. Poland, Kent University, but professor from the Kent is now moved to the Hong Kong, yeah. And Bangladesh, Italy, and so on. Yeah, European Space Agency, we also work together. And now one of my staff is moved to the European Space Agency. And Bangladesh is one of our researcher. And also Lapan, yes, no Lapan to be BRIN. And in BRIN is maybe from the more than 5 of PhD is from our laboratory, maybe more than 10. Yeah, now is Pak Asif is next December 14 is to be the professor in BRIN. Yeah, okay, this is it's very good, news. Yeah, and the other one is also I work for the big scholarship foundation in Japan. Yes, because I'm the counselor of the Satoyo Scholarship Foundation and also the Atsumi International Foundation. Yes, it is a good chance, yes, to get the scholarship, and you can enroll and learn about the microsatellite or the microwave sensor in Chiba University or another university in Japan. Yeah. And also I create the Twinkle program. It is the Japanese student, because Chiba University send 100% of the student must learn overseas. Yeah. So I created many program. I started with the 5 university in Indonesia, and then now is to be in the Malaysia. Yes. Also including the Cambodia, Vietnam. Yeah. And also with the Twinkle program. Okay, yes, and the other one is the Global Study Program. Okay, we have many programs here, yeah, and I hope you can searching and get this opportunity to learn in Japan, or you can also receive the student from Chiba University. Yeah, because I send almost every year is more than 100, 200 students to Indonesia. Yeah, I hope this is also a good chance for you to increase the KPI. Yes, upon the international, collaboration. And okay, in the company also we have worked together with many company here, including Sumitomo. No is one of the student from the Sumitomo. Yoshimoto-san is also here, and also organization, political reason. Yes, I hope I have many best friend in Indonesian, uh, uh, cabinet, and also in Japan cabinet. Yes, I think it is also a good opportunity for us to make the collaboration between these two countries. Okay, yes, the collaboration, and I made, this Indonesia-Japan Joint Scientific Symposium is since 2004. Yeah, and now it's to be more than 10 times. Yeah, I hope we can start again because after this COVID is we can gather together. I hope in the future, near future, we can do also this IJJS and also in UNS here. Okay, next. Yeah. Okay, I talk about this one is because today my topic is about the collaboration. Oh, how many minutes? Sorry, I'm still have the remaining time. 15 minutes. Still 15. Okay. Okay, next. Yeah. Yeah, it is okay. Please skip this one because in here it's just now we develop for the 2 hour of the endurance of the flight. Yeah, and it is in the system that we already established for L, CX band already proven, and the L band it is for the microsatellite. And okay, for the details you can read my book for the airborne SAR here, and for the UAV SAR here, and for the microsatellite SAR is in this book. Yeah. Okay, for the young student here, please every day if you have some new thing, please always take the memo. Yeah, this memo is very important to for the future if you want to submit the patents, and also for the publication at the journal, and also the books. Yeah, because every day I'm writing the book. Yes, at least is 2 or 3 pages. Yeah, and if 2 or 3 pages, you can times, in 1 year, it's maybe 1,000 pages. Yeah, so why I'm almost every month, every year I publish 1 or 2 books. Yeah, because every day I'm writing books. Yeah, so it is, I think is please also do thing because the number of Indonesian people is almost 300 million. Yeah, it means if 10%, it's just 10% is writing book, I think Indonesia have many books. Yeah, it is very good for your future. Yeah. Okay, next. Yeah. Especially for the lecturer here, please writing books. Yeah, it is very important. Yeah. Okay, it is my drone that GX2S. Yes, from the sensor. Yeah. It is in the sensor that we developed, for example, in the L band. Yes, it is the antenna developed by my student now, already the professor in Universitas Negeri Padang. Yes, Pak Yohandri. Oh yes, this one is Pak Yohandri is already a professor right now. Yeah. Okay, yes, it is just in the example. Okay, next is GX2D. Yes, for the dropping. Yes, this gray color, it is in the container. We have the 2 container. Yeah, and our invention here is about the gravity controller. Yeah, gravity controller from the UAV. Yeah. Okay, next. Yeah. Yes, it is some project with the commission. It means we got the money. Yes, from some company. From Indonesia is we developed for the Pertamina. Yeah, Pertamina from the K band and also the KU band. Yeah, this is to offset the oil spill because we have many offshore, oil rich. Yeah, and then sometimes it's the accident that fire. Yeah, especially in the nighttime. Nighttime is very difficult to observe, and we developed K and KU band radar. Yes, it is to observe at the Kepulauan Seribu at the northern part of the Jakarta. And the other one is, yes, this one, we work some of the company and also Taiwan Aerospace Agency for the airborne SAR and for the microsatellite SAR, and also for drone. Yes, you can find it in the money. Yeah, and the SATREP, JICA GST program, and so on. Yeah, I think it's, yes, we have also still many. Yes, almost every year is about, yes, more than 10 million US dollar. Yeah. Okay, next. Okay, from the mission itself, we develop, some collaboration to some of the mission here, disaster monitoring, including we also work together with the Chiba province, yeah, to observe the, like we have a bad experience at the Atami, yeah, about the landslide, yeah, and now we monitor of the Chiba area about the landslide itself. So in this case, is yes, landslide precursor, yeah, using the synthetic aperture radar, and also we put some of the sensor, yeah. Another one is the natural resources observation. Yes, we like the oil spill monitoring and so on. Yeah, the search and rescue is BNPB. Yes, because Indonesia have many disaster, and we work together with the ITS. Yes, Institute Teknologi 10 November about to develop is low cost GPS. Yeah, to predict the earthquake and also the volcanic activity. And the other one, home security and anti-terrorism mission. Yes, fortunately, Indonesia is not, the terrorism is reduced. Yes, I hope we don't work for this one. Yeah, yeah. I hope we can work more for a safe one. Yes, and I think we still need for the maritime surveillance. Now we work also with the Japanese government is for the maritime surveillance. Okay, another one is the infrastructure monitoring. Here is it is very interesting. Now we work with the insurance company in Japan. Yes, to how to predict the disaster, and then we can reduce the claim of the insurance. Yeah, because every year is the insurance company is lost more than 2 billion US dollar. It's not rupiah. Yeah, billion US dollar. Yes, on about how to reduce, yeah, this insurance. Yes, claim. It is also very important. Okay, for the disaster monitoring example, you can read my paper in IEEE TGRS. Yeah, it is about the, the Lapindo. Yes, it is we observe using the synthetic aperture radar too. Okay, next. Yeah. Panwar, please mention me if the time is already over, because I prepared many slides. Yeah.
Okay.
Okay. Yes. Compared to another system here, like the JAXA, it is made by the Mitsubishi and also the NASA and DLR. It is all of the using the linear polarization, horizontal and vertical. And then we develop, it is our original, it is in the circular polarization. You can get more detailed information about the circular polarization from my book or from many paper, yes, published in my laboratory. Yes, and now is some of the institution in the world is started to develop the circularly polarized synthetic aperture radar. Okay, next. Yeah. Yes, it is some, we work together with many institutions. Yes, including in Indonesia, Germany, also from Malaysia, and another is from where? Yeah. Yes, Indonesia itself, UGM, UE, LAPAN, noise to be brain, and LIPI, yeah, noise also to be in the brain. Yeah, it is all is my student, and I hope some of them is very close to being the professor. Yeah. But already four is professor right now. Yeah. Okay. You can. Okay. Next. Yeah. Yes. It is. We developed for the Cessna, and we developed a new material we call the polymaterial. And this polymaterial is very light and very strong. Yeah. And then we prove in this experiment at Yogyakarta. and after back to Japan last time, and then the SoftBank, you know, is interested to our material, and now they use for the tower of the 5G and 6G. Yeah, and then they want to change all of the tower using this material. Yeah, it is very good business. Yes, and it's very, you know, big, maybe billions, you know, project. Yeah. It is the C-band SAR that we install in the Cessna, yeah, at the Yogyakarta. And we develop all of the system, and including the antenna. It is developed by Cahya Sang, yes, at the BRIN, yes, right now. Okay, next. Yes, next is the CN235 aircraft. Yes, we install in this aircraft. The antenna is full polarimetric SAR. It is in the circular polarization. TX is the right and left, and also the receiver is the right and left. Yeah. Okay, next. Yes, when we install in the CN235, it is very thanks to the Indonesian Air Force that support us to realize this radar. Actually, you know, this radar is my dream, and I said to my father when I'm 5 years old in the city. Yeah, when you landed at Adi Sumarmo, that's the runway is actually my father is over there. Yeah, and then if you want to find the name of my father inside the building of the Indonesian Air Force field. Yeah, and over there is the place that I, you know, said to my father that I want to realize the radar. Yeah, and it is the, you know, finally I realized this radar in, you know, in here, and in 2018. Yes, and yes, I finished to, you know, it is what I said to my father. Okay, next. Yes, we install like this one from the ground test with, and we touch the radome using the counter reflector. Okay, next. Oh yes, we did this one is Lanut Hasanuddin. Yeah, and then it is our first images of the synthetic aperture radar. And at the same time, we recorded it is you know, with the cloud, and then you can find is you know, it is very clear. Even, you know, the speed is not stable, but it is our first images. I think the historical images that of the circularly polarized synthetic aperture radar. We got the full polarimetric SAR images. Next, yeah. Okay, yes, it is some part of the image that we get, and this, you know, microwave can penetrate the building, and you can get the pillar of the, you know, building here in the pillar inside the building. So, yes, it is the what is some of the building in Lanut, Hasanuddin, and Makassar South syllabus. Okay, next. Yes, it is the full polarimetric SAR images. Yes, L is the left-handed circular polarization, and right is R. Yeah. So cross polarization and co-polarization. Co-polarization is, you know, more, you know, weak compared to the cross polarization. It is the opposite compared to the linear polarization. For the detail is in my paper, and about the characteristic and the application using the full polarimetric for the circular polarization images. Okay, next. Yes, it is the one of the image and the southern part of the Makassar. Okay, just could you just flow? Yes, because we don't have so time. Yeah.
3
Yes,
minutes.
yeah.
3 minutes.
Oh, 3 minutes. Yeah, this is for the ship detection. Yeah, it's very clear, and you can get also some of the scattering from the telecommunication system. Yeah. Okay, next. Yeah, just flow. Yeah, it is just the example of some images. Yeah. For the mangrove observation, yeah, because we work with the Indonesian Maritime Minister of the Maritime. Yeah. Okay, and this one is for the BPN, Indonesian Land Management. Yeah, now we work together to about the automated how to mapping of the Indonesian land, because now we still have 34 million bidang, bidang on the parcel, parcel of the land is not yet have the certificate, if if we already could mapping and get certification, and you can get the tax, if one parcel is, for example, 1 million rupiah, it means the country can get more money. Okay, next. It is from the microsatellite SAR that developed in our laboratory since 2007. 2007, with my student from Pakistan, Indonesia, Malaysia, Brazil, and so on. Okay, some next. I hope you can also enroll to my laboratory. Okay, this the application. Just scroll. On the backscattering coefficient, yes, it is. You can read my paper that about how to estimate the cool. I think it's even the cool is not so trend. But I don't know. Maybe in the future we can still use. Okay, it in the earthquake of the Central Java. Yes, using the coherence monitoring. Next. And next, the interferometric. Yes, it is about how to estimate the land deformation. You can read my book paper in IEEE TJRS. Yes, about horizontal change and vertical change. Next. Okay, next. It is to process about the Lapindo observation. Lens accident and the hot mud flow. I observed the Lapindo since 2006 until today. And Jakarta subsidence. So why for example, at Halim is flat, and also BSD also flat. It is because the lens subsidence. Okay, next. So this one is estimate the volcanic ash, the thickness. Like today is the Marapi, Marapi Mount at the Sumatra is explosion. So it means you can also estimate using this DINSA, differential interferometric sound. Okay, then my new paper, related the spotted out hot mud flow from the Lapindo at Sidoarjo. Okay, next. I think the time already over. Yes. Okay, thank you very much. Yes, I hope you can know that the collaboration is very important. Yes, please, especially for young student here, please do the collaboration and make many friends. And also make many colleges. I think it's very good for your future. Okay, thank you very much. And time I give back to Pak Anwar.
Thank you very much for Josh for giving us such comprehensive presentation. Ladies and gentlemen, we now come to the Q&A discussion session. You can raise your hand in this room. Any question? Or from Zoom, maybe you can directly raise your hand if you have any question for the presentation. Any question? Maybe for student, you can use Bahasa Indonesia if it's not good for you. Student, the second floor, do you have any question? No? Oh, please.
Thank you. Prof. Sahabat, maybe my question is not about scientific but administrative aspect. Right now, Ministry of Education Indonesia have a program namely Merdeka Belajar Kampus Merdeka. Maybe in English, independent study on independent campus, maybe like that. The program is the student have a possibility to study outside of university about 20 credits. Yeah, if I don't mistake. Yeah. So my question is, how Chiba University to collaborate with the university in Indonesia to perform the Ministry of Education programs. Yeah, especially for bachelor program in Chiba, for example. Yeah.
You want to send the student to Chiba University, you mean?
Yeah, maybe
Yeah, okay.
in the future.
Yeah. Okay, thank you very much. Yes, we have many experience. Yeah, almost every month is we receive the student from Indonesia. Yeah, I think it's my student here is no. Yeah. Oh, and also Mbak As, yeah, you can ask also her. Yeah, he just came back from my laboratory. Yeah, he stayed for 1 month. Yeah, yeah. For the program, uh, to learn just it's very short. Yeah, it is also under Merdeka Belajar, and also before is the Universitas Negeri Padang. Every year is they send for 6 months or sometimes it's 1 year. Yeah, it is just for like the internship or magang. Yeah, no no degree, yeah, non-degree program. Yeah, it is also is possible. Yeah, and I hope from Universitas Jenderal Sudirman also you can learn. Yeah. Actually, Pak Jamrod is also our student before. Yeah, no, he is the lecturer at Universitas Jenderal Sudirman. Yeah, for the we don't have what is um, uh, the requirement. Yeah, but if already register in your university and you recommend to us, and we can consider later, and I will arrange in my department. Yeah. No, I'm to be the head of the division, some of the research center, and until last year is I'm head of the department and head of the division that I manage 3 departments, yeah, in Chiba University. I can help you. It's not just to the Department of Environmental Remote Sensing. And if you from the Department of, for example, the Urban System Engineering or PBK, and also the Department of the geoscience. Yes, it is geology in Indonesia, or sometimes it's geodesy and geography with the geo. Yeah, it is. I can also arrange and help for you. Even the Department of the Law and so on, horticulture on the agriculture is. I can also help you. Yeah, please call me. Yeah, I will, because every program have different characteristic. Yes, and also a different background, and also different budgeting, how to arrange the with the good cost performance. It is including sometimes the most difficult to arrange is in Japan is for the housing. Yeah, the housing. Please inform me before 1 year. Yeah. At least it's 6 months before the student come. It's more easier for us. Yeah, because sometimes it's very difficult. And last time it's like he stay with another 3 students. Stay in my house. My house is okay. It's large. Yes, so you can stay in my house too. Yeah, but it's too many. So I cannot do it. Please give me time to arrange to all of you. Yeah, thank you very much. Yeah.
Okay, thank you very much. You can discuss later for the more information about the double degree, for example. Yes. Okay. Okay. Any other question from this room? Okay, please, Dr. Johan from 11 University.
Thank you very much, Mr. Dr. Anwar, Professor Jasafat. I have some questions related to your work. You have done with many work for satellite. This is when I was graduate from university, I was joined to a company, Pacific Satellite Nusantara. This is also the satellite company. I try to find in the different view of the research area and also commercial area for the satellite. Actually, I don't really understand that if business side want to launch the satellite, they also try to find like business part like transponder and many things about communication and others. And in the research area, we also have, for example, image sensing or kind of radar or something. This is actually this is a different part, or we can merge each other. So we have one satellite with many things of cooperation we can did in this part. I think this is a more useful for Indonesia. I mean, we have one satellite, but it can serve in many things like communication, also research area, and also for business part. I hope your opinion, and thank you very much.
Sorry, may I repeat your question? You imagine that we prepare the satellite for many purpose, you mean?
Yes, right.
Yeah. Okay, yeah, yes. Ideally is, yes, like you mentioned, yeah, that we prepare the project on the satellite is for many purpose, yeah. But sometimes it's very hard, yes. Like in Japan, it's like for the JAXA, yeah, JAXA is launched the satellite for many purpose, yeah. Like the JERS-1, JERS-1 is a little bit for the experiment, yeah. After that, the ELOS, ELOS-2, and noise ELOS-4, yeah, and another. Yeah, this one is for the scientific and also for the operation. Yeah, operation is it means for the disaster monitoring and so on. And some part of the images like ELOS-2 is sell for many people can buy and use. And I think it's from the rest here is very bad. Yeah, that. Yes, it isn't the ideal. But if we consider to satisfy all of people, it means you must realize it's very tough satellite. Yeah, tough satellite is means for all purpose satellite. Yeah, it means your satellite is to be big. Yes, like the JAXA or DLR is developed. Yeah, but in our case, it's different. Yeah, we developed the microsatellite, especially in our laboratory. Yeah, it is just for the testing, and then for the scientific purpose. Yeah, and I think it's for the brain is for the first is okay, same. Yeah, but I don't know. In the future, is maybe we'll give the surface. Yeah, and no, I think Indonesian government plan to realize it's very big synthetic aperture radar. Yeah, it is for the mapping purpose. Yes, and also for the agriculture. Yeah, and then what is for the maritime observation. Yeah, but from the defense is different. Yes, sometimes yes, I know. Yeah, this one is more high precise. Yeah, but it is from the civilian and from the defense is different. Yeah, so yes, first is the most easy one is from the civil or from the defense. Yeah, and then from the civil is for like you mentioned is for scientific purpose on the business. Yeah, even the business. Yes, you prepare from the business, but you must also consider some part is for the scientific. Yeah, because for the calibration and so on. Yes, to improve for the next satellite is I think you need the scientific side of the developing. Yeah. Okay, this is just my opinion. Yeah. Yeah. Okay, thank you very much. Yeah.
Okay, thank you very much, Prof. Josafat. Due to the time limited, we need to end our discussion session. Thank you very much. Give applause to Prof. Josafat. Thank you. And ladies and gentlemen, let's take a break for 5 minutes. Yeah. And after that, we're going to take our last part of session. Yeah, with our last presentation after 5 minutes. Thank you very much.
Thank you. Okay, thank you to Professor Joseph Patetuko for the materialization.
And now we can move on to the third keynote speaker from Dr. Pega Hasemfat Kiabani, International Capacity Building on Remote Sensing for Asia and Africa at Remote Sensing Technology Center of Japan. For Dr. Pega Hasemfat Kiabani and the moderator Dr. Miftahul Anwar, the stage and the session is yours.
Ladies and gentlemen, we are going to listen our last part of presentation. Yeah, presented by Dr. Pega Hasemfat Kiabani. Yeah, to present the material of international capacity building on remote sensing for Asia and Africa. Dr. Pega, please come to the stage. Dr. Pega received BSc and master degree in Faculty of Agricultural Engineering and Technology at University of Tehran. She joined the Department of Civil Engineering at University of Tokyo for PhD, specializing in remote sensing of the environmental and natural disaster. Her doctoral research focused on the application of space-borne and airborne remote sensing technique to model oil palm yield in Malaysia and Indonesia. Her work was characterized by the depth utilization of multi-source data for achieve comprehensive insight. And she was also a remote sensing researcher in Solution Service Department of Remote Sensing Technology Center, RESTEC, of Japan since 2020. Yeah. Ladies and gentlemen, allow me to welcome Dr. Pega.
Good afternoon, everyone, and thank you from Dr. Anwar to introducing me. Thank you for the opportunity to having us as a Remote Sensing Technology Center of Japan here. I should give a special thanks to Muriyama Sensei for inviting us as the private entity from Japan, engaging into different aspects of the Earth's observation and capacity building, to be here and present and introduce some of our activity with the hope that this kind of activity will be useful for the young generation. It's really difficult for me to talk here because I see so many of my teacher and mentor here, and it's really difficult to talk about techniques and the basically very details of the remote sensing, but I rather explain how we try as a Japan Earth observation community, how we try to transfer our knowledge and technology to the other part of the world, especially Asian country and also Africa. My name is Pega, and I'm from Remote Sensing Technology Center of Japan. And without further ado, I would like to move to my presentation. I try to keep it within the 30 minutes and don't go over time. But I would like, before diving to main topic, which is international capacity building, I would like to touch a little bit about my organization, about the history of the Remote Sensing Technology Center of Japan, about the activity that we do. That hopefully will give you quite detailed perspective on how we can support and transfer our knowledge and technology to other part of the world. So as the name suggests, and I mentioned from the beginning up to now a couple of times, RESTEC stands for longer name, which is Remote Sensing Technology Center of Japan. And we are quite a old entity and organization in Remote Sensing Society of Japan. And we have been established in 1975 under the current version of the Ministry of Education and or so-called mixed. Our main activity usually involve with the research and development of on the field of remote sensing, and also we highly contribute in the promotion of the remote sensing and different application of remote sensing. Here I brought you a very detailed history of my organization, which I am also new to this organization, with 4 years old in this organization. So I'm not really engaged into the whole history, but I would like to bring your attention to the part which is related to today's topic, international capacity building. We started this international capacity building activity in 1998. So you can imagine that through the years, we successfully accumulate lots of experience on this area. Would you please go next? Here I brought you some details about how we basically run our business and what are the different sections in our organization. We have basically 6 pillars for our organization. The main pillar that we work on and the main part of our organization is basically satellites, Earth's observation. In this part, in this section, we not only we work with the downstream, which is the application, we also work with the upstream, which is data acquisition, satellites operation. And on that, we closely collaborate with the Japan Aerospace Exploration Agency, or JAXA. And through such kind of work, we accumulate quite a bit of experience in different aspects, from the upstream to downstream, from the data acquisition, operation, to the different application of the remote sensing. The second most important pillar to our organization is our research and development section. Which, as you can imagine, having the experience and having the partner, being the partner of Japan Aerospace Exploration Agency, we always think about how we can improve our techniques, algorithm, reliability of our information and our maps and data. And this huge responsibility is on the shoulder of our researcher from the research and development section. And next to this research and development section, we have a section which basically I belong to, which is solution service department. And the main responsibility of this department is to bring basically to make this bridge between industry and academia, between what we do in laboratory and we do on the research, bringing into the actual application and bring it in the society and bring the benefits. So we always search about how we can bring different data into the real case application and how we can bring the power of the data for policy making, for the implementation and things like that. Next to us, we have always a think tank team, which they always analyze the different trend, different approaches, and basically they analyze day by day about the trajectory of remote sensing knowledge, and we work together to bring the knowledge into the best case that we can. And having those experience from research and development, social solution service, and think tank, we always work with our capacity building team. which we not only focus on the Japanese market and Japanese basically remote sensing community, we also care about the Asian country, Africa, and recently we globally extend even to Europe as well. So in this capacity building section, we try to, based on the requirement of our end user, we try to tailor-made our course and present our course and transfer our technology to the end user. And at the end, we use all our expertise to promote whatever we can on the Earth's observation and potential of the Earth's observation in our community. Would you please go next? This is a very brief introduction about our offices. We have 3 offices. The headquarters, of course, is in Tokyo. Would you please go next? The second important office that we have is located in Hatoyama. And this is the place that our basically office is located in the Earth Observation Center of JAXA. And this is the place actually we contribute to the upstream operation, data acquisition, not only those, but also, for example, developing the ground systems, validation, calibration, all those activities engaged to upstream. The other office that we have is in Tsukuba, but this one is in the Earth's Observation Research Center of JAXA. And as you can guess, the main activity is involved around the research and development. And we try to take the advantage of our location and partnership with JAXA and try to find the best approach, the best methodologies, a reliable product based on JAXA's observation on different satellites. Could you please go next? I'm sorry, the font seems to be changed from what I have, but it's okay. Still, it's readable, I guess. So basically, from now on, for 2-3 slides, I try to just give you some perspective in the case of application in what field we basically work. One of the important fields that we work is the field of agriculture. In the agriculture, we have different partners from private sector, insurance company, to the government, Ministry of Agriculture, Forestry, and Fishery. We take the advantage of the data and the archive that we have from the different observation to best provide product for our partner. One of them is this example, which we have our own algorithm to fuse the imagery and observation from the I guess planet, and then with the UAV imagery, and based on that own made algorithm, we can estimate the height of the rice, which is a strategical crop for Japan and Asia. And that estimation of the height of the rice would help us to estimate about the yield and productivity of the crop. And that's why some insurance company also are interested in such kind of activity. We work on rice, but this is not the only crop that we work. We also extend our expertise on the maize and sugarcane and corn as well. The next application that we work quite extensively is forestry application. One of the best case example that I can present here is the support and collaboration that we have on the JJ-FAST program or initiative. JJ-FAST is a collaboration, an initiative between JICA and JAXA for the early warning in forest, basically forest early warning system, because JAXA is equipped with the L-band SAR, which has quite a good potential to penetrate into the canopy of the tree. This data is one of the best data that we can get for forest application, especially around the tropical area, which around the year we have the issue with the cloud cover. So This initiative helps not only tropical country, but also all the country on the globe to have the early warning notification on the deforestation in their study, in their area of interest. Well, we, as a Remote Sensing Technology Center of Japan, we collaborate in two different sides of this initiative. From JAXA side and system development, we support JAXA in improving the algorithm, maintaining the algorithm and their portal. But in the case of the collaboration with JICA, we support for the capacity building and transferring knowledge to the partner that we have and the country who deal with the deforestation quite drastically. And this is one of our best case example that we, on daily basis, we work on the forestry. Would you please go next? Another example is disaster monitoring, being Japan as one of prone country to earthquake, flooding. We have quite a bit of expertise on the estimation of the extent of damage, especially in the case of earthquake and flood. Here I have the example from our own made algorithm that we combine the optical imagery with the surface elevation model to estimate the depth of the flooded area, and we present with a good reliability, and we present such kind of data and information to government for the disaster, basically after disaster management after the disaster. And we also use, again, taking the advantage of being partner with JAXA, we use so many SAR archive for the flood monitoring as well. Would you please go next? We work not only on terrestrial area, we also work on the marine land as well, marine area as well. In the ocean, we have a couple of activities. One of our activities to try to take the best out of the Himawari observation. With the own-made algorithm, we have our sea surface temperature distribution maps around the West Pacific Ocean and Indian Ocean. And that's not the only case of the ocean application. We also have a bathymetry map, which has been developed by the researcher in our organization. Would you please go next? In the infrastructure part, we also developed our expertise based on different data, and one of the best case example is AW3D, which is a very high resolution and precise surface elevation model. With that, we work with different private and governmental organizations how to maintenance the infrastructure in urban area. Would you please go next? And with that, I hope that by now I could give you some very basic image on what are our basically experience and expertise. But from now on, I would like to move to the main topic, which is about our capacity building program. As I mentioned, we have been working in the capacity building and knowledge transferring field for quite a bit of time. And so far, still the graph is not really updated, but so far we have more than 7,000 individuals which we interact with and had a training over 88 countries. Around 2,000 of them were non-Japanese foreigner individual who we could transfer our knowledge and technology to them. And from now on, I try to give you some examples how this framework basically works and how we present our capacity building program. Would you please go next? So in terms of the field and the expertise that we transfer, we are quite a bit diverse. We have different researchers from different dimension of this chain of the Earth's observation, from the very upstream to the downstream. So we can, based on the requirement of our basically partner agency, we can tailor our courses. We can start from the very basic of fundamental of remote sensing and GIS, and then we move to a little bit higher level of the interpretation and working with the optical sensor, and then moving to SAR sensor. We also can present some, can transfer some knowledge in terms of the upstream management, in terms of data acquisition and reception, satellites observation, and the satellites development itself. So in terms of the team or the area that we can offer the capacity building courses, we are quite diverse, and we have the expertise in different part of this chain. Would you please go next? This map still cannot, I mean, we have not covered all these countries, but as a continent, we could be partner with so many countries in Asia, Southeast Asia, especially, and in Africa and South America. Here, I brought you some example more on the Asia part, and then in the later part, some example from African side as well, to just show you how this collaboration works. Would you please? One of the, again, excuse me because of the font. The font seems to be a little bit not uniform in this slide. But anyway, one of the best case example of our recent capacity program activity can be the collaboration that we had with the Vietnam space agencies. As a background of this activity, I can say that in 2022, JICA signed an agreement with the Vietnam government to support and give a loan for the satellites development, and specifically on the project of disaster and climate mitigation using the satellites observation. In this program, basically, the ultimate goal was to reduce the risk from climate change and disaster for Vietnam, and try to improve the response of the government in the case of the disaster. And through the financing, the government, JICA, basically wanted to support the government for procuring the data, procuring some of the equipment, and supporting the Vietnam government for the transferring knowledge and technology. In the same area, because of such kind of activity and collaboration, Vietnam Space Agency started establishing its own expand SAR satellites called LutuSat, will be launched hopefully in 2024. And along with the launch of these satellites, JICA requested us to support the knowledge transfer and capacity building for the VNSC, or the Vietnam Space Agency. Since this is a long-term basically program, we also tailored a long-term capacity building program or training program. In this case, our capacity building program has 3 phases. The first phase is basically for the long-term training, which we hosted officer from the Vietnam Space Agency to stay for more than around 6 months in one of our partner Japanese university, which in this case is Tokyo Technology University, and we support for their livelihood and visa and all the matters related to their stay in the university. We support the research development as well in terms of the methodology, topic, in terms of evaluation of their research and things like that. Beside our long-term training courses, we had 2 short-term training course as well. One of our training course, which we concluded in this year, was around 4 days, which we basically try to build up from the establishment, from the fundamental of the remote sensing, optical, SAR, and then application of different data. And then in the next year program, we have another short-term program, which we try to transfer the knowledge specifically on the X-band so that the officer can support their agency in terms of the data utilization of their own satellites. In these courses, we not only focus on the technique, we also support officer how they can also transfer the knowledge that they gain in Japan to their colleague in Vietnam, because in terms of the number, we had some limitation. So would you please go next? Here I brought you 2 examples of those short courses and the contents that you can see. Both of the courses are 54 days. And in the first courses, as I mentioned earlier, we mainly focus on the build up the establishment. So we try to bring our knowledge for them in terms of the fundamental of GIS, remote sensing, optical sensor, SAR sensor, how to process with different software, ArcGIS, Google Earth Engine, and things like that. And in the second example, we mainly support them in different project-based learning. So all the trainees at the beginning with such background, they selected a specific area of the interest, and we support them how to develop their basically methodology, their processing, and the logic and rational from the beginning. And that's why you see so many case studies from landslide, flooding, agriculture, and each of them, they are in different platforms. Some of them, they have been done in Google Earth Engine, some of them using the traditional methods, using ArcGIS or NV and such kind of software. This is the example that we had with the Vietnam Vietnam Space Agency collaboration. Could you please go next? And this is some photo and documents from our training, and it was really happy news for us to hear that our partner from BNSC, our colleagues, also satisfied with our course. In different part, you can see some summary and their satisfaction level about our courses as well. Would you please go next? Another case example is our collaboration with JAXA, bilateral collaboration. As you probably are aware, JAXA is also collaborating with so many space agencies, ministry around the, especially Southeast Asian country. We support JAXA for transfer the knowledge and expertise as well. This is one of the recent example that we had was a tour that we had around 4 countries in Southeast Asia, Thailand, Vietnam, Indonesia, and I forgot the third one, and Philippines. That we try to promote and facilitate the utilization of L-band SAR specifically on cloud computing platforms. And we mainly specifically here work on the developing the skill for working with Google Earth Engine, that probably you have heard about that. Before such kind of activity, we always discuss and consult with our partner agency, for example, Green or VNSC or PhilSA or GISTA, to know the requirement in what kind of field there is a need for transferring knowledge, and based on that, we tailor our course. And in the case of this collaboration, recent collaboration that we work alongside with JAXA, we try to, in each country, we try to provide two different sessions. The first session was a public session, which we hosted quite a big number of individuals, and we did not go into the detail of technique of how to process with the Google Earth Engine or how to use L-band SAR on the Google Earth Engine archive. We rather cover the fundamental knowledge of how SAR can be useful for different applications. And we called that the workshop for end user, and that was the one of our workshop which was open to public. But follow up with that workshop, we worked with the limited number of the space agencies officer to specifically work on the coding skill and working with the Google Earth Engine and L-band SAR data on Google Earth Engine on a specific application. For example, in the case of Indonesia, application was mangrove, basically monitoring in different locations, different application based on the requirement of the collaborator agency. That was one of our basically capacity building or knowledge transfer course. Would you please go next? This is another example of our collaboration. I see so many young also participants in the second floor that might be also useful for them. This program is basically Japan Asia Youth Exchange Program, or so-called Sakura program. Traditionally, this program has been focusing on Asia, but recently the scope has been opened up to globe. And the funding agency here is Japan Science and Technology Agency, or JST, and they support financially students to come to Japan and to transfer not only student but also officer from Ministry of Agriculture, different ministry as I know, to come and transfer knowledge. And the baseline perspective and rationale is to connect individual young researcher around the world so that we can build up our knowledge and pull up our remote sensing community. These are a couple of examples that we have. We have done this program for quite a bit long time, since 2017, I believe. And usually we have, depending on situation, it might be a little bit different, but usually we have 10 days of training, including lectures, hands-on, and some project-based learning. So we start with some lecture, which we describe some techniques and theory of things, and then we move to hands-on training so we can transfer our knowledge and our skill in using different platforms and software. Usually we conclude this course with some sort of project-based learning or some sort of report that we ask all the participants to try to think of their own country and how we can bring the potential of Earth's observation imagery into the real case application. Would you please go next? Yes, this is another example which is related to very first slide that I talk about JJ Fast, basically initiative between JICA and JAXA. As I mentioned over there, we contribute in both sides of this initiative, contribute to system development along with JAXA, and also we contribute in capacity building and knowledge transfer along with JICA. And again, from since I guess 2017, we have been working with JICA, and every year we except those years we tackle with Corona, we accepted trainees or participants from so many parts of the world dealing with the deforestation issue, especially in tropical area from different countries in Africa, in Asia, Malaysia, for example, Myanmar, Gabon, Philippines, Botswana, Peru, so many countries. They usually come as a batch, and we have a month of training for them. And here I put you in last 3 weeks, we have a group of people coming from Brazil under the same collaboration and framework. And this is the program that we designed for them. And you see that from the beginning, after their arrival to Tokyo, we have a couple of courses to work on the theoretical background of SAR, because again, SAR is, especially L-band, is really useful for the forest management. We cover a little bit on the background, and then we move to the actual application. So we basically provide the material and teaching facility to them to learn how to work with the JJ-Fast system, how to work with different software and cloud computing platform and SAR data. And again, similar to other programs, we usually conclude this kind of program by project-based learning. So we support them and ask them to develop their own project in their interested area of their country. And we work along with them to for example, get some information about deforestation, extent of deforestation, time, and things like that. Usually such kind of course, we also offer multiple site visits to show the showcases, for example, for the forest management in Japan, or we have some site visit from JAXA facility and laboratory as well, which we think that is also helpful to understand the whole chain as well. Could you please go next?
3 minutes.
3 minutes, I'm all done. For the last 2-3 slides, I just covered the African case. We have also been working with African countries for transferring our knowledge and technology. One of the case is actually the collaboration with Congo, which at the beginning start with the fact that there was an agreement between the Congo government and Japanese government on utilization and partnership on satellites observation. And on that collaboration, under the same framework, Japanese government asked us to organize some workshop, basically 2 workshops, one in Congo and the other one in Japan. In Japan workshop, the Ministry of the Education and Technology of Congo mentioned the necessity of having and establishing the center of the National Center of the Telecommunication, and that was the first idea of the collaboration between JICA and the Congo government for building such kind of facility. And on that task also, we support transferring some technology, also some maintenance work as well for their facilities. Would you please go next? This is another example from the South Africa, which this is way back before I came to Restec, so I'm not really aware of the detail of the collaboration. But again, such kind of collaboration was on the under the framework of JICA and the specific here in this case South Africa National Space Agency, and we support transfer knowledge and capacity building. For the, would you please go next? As the last slide or last part, I would also want to emphasize on the point that although we are a private entity, but it's the business and the profit is not our only goal. We really care about promotion of the satellites and the utilization of the satellites observation. One of the example is this free of charge web-based algorithm called a web-based application called the Vega sorry, visualizing Earth tool by Google Earth Engine app, which for those people without any background on remote sensing, this application easily and in a very user-friendly way support them to just bring out so many different sensor and visualize the data on their screen without any hassle of the downloading data, downloading the software or registration. So I would request you to also check this with the keywords of Vega under the on our website. You can find so many tutorial. We also have a YouTube channel for that, which the manual is quite straightforward, but if you think it would be helpful, please take a look at. Would you please go the last one? And in the last slide, I would like to emphasize that we are not, although we have been working in the area of capacity building on the remote sensing, but we are not funding agency. So on our own, we are not able to support. But in case that there is such collaboration with JICA, with the government, ADB, or JST, we really will be happy to support you and transfer our techniques and our knowledge to you, with the hope that eventually everybody in our community understand the full potential of Earth's observation data, and we can bring them in policy making and actual implementation. Thank you so much.
Thank you very much, Dr. Priya, for such informative and comprehensive presentation. For the last part, ladies and gentlemen, now we come to Q&A or discussion session. Yeah. Do you have any question? Please raise your hands. Or from Zoom, do you have any question? Participant from Zoom. Any question? Okay, I have one question about the I saw about the Sakura exchange program. Yes, this is the program for only the researcher or also the student to take capacity building in your place.
I believe it's mainly focused on the officer from the government agency, like the Ministry of Forestry or Agriculture. But since they're revolving and redesigning the framework, there might be some update that I'm not aware of. So I really encourage you to check the website, because traditionally they used to target only Asian country, but now they are expanding the area to whole globe. So there might be some opportunity for students and researchers as well.
I saw some of your slide. You have data from Indonesia.
Yes.
So, what kind of collaboration you take part from Indonesian government?
So at the moment, my knowledge might be limited because we are working in different division. The division that I'm working, the collaboration that we work and capacity building opportunity that in my section we provide for Indonesian partner is more on the framework or RESTEC JAXA collaboration. So this is JAXA, and in the case of Indonesia, BRI, who have the agreement, and under that agreement, JAXA requests us to provide some training or knowledge transferring courses for Indonesia.
And usually also for JICA, yes?
Yeah, also JICA.
Okay, any other question for this last presenter? Any question? Okay. Pak Johar first.
Okay. Thank you for your presentation. My name is Hamka from Universitas 11 Maret. So last year we have some kind of like initial project for monitoring the agriculture or pepper plantation in Magelang. But the problem is we have limited resource of the data. So actually, what we do as a maybe researcher or a university is usually initially we do some kind of like proof of concept using the satellite data, and then we prove that it can be useful. But yes, the problem is the funding is not it's not available yet. So we just use the resource like the free available resource like from the ISA, Sentinel, something like that. So with the Restek, is it for the initial phase, we can get some resource that we can use, for example, the data for example, for that kind of project. Is it possible?
So the majority of the data that we support belongs to the copyright, and all the property rights belongs to JAXA. And in this case, usually the framework is that from your agency, if mutual agreement between your agency and JAXA, JAXA would request you to give a kind of simple proposal for your research and expressing what kind of data in what way. Yeah, what kind of data in what way would be useful for you? And in majority cases, usually JAXA is really open to share data, especially for the field of research and development. The business would be a little bit different, but for the research and development and working with the university, JAXA is really always really open as far as I know. So, but Restek itself, because we are not in majority of the cases, we provide the data, we are this data distributor. So without the acknowledgement from the data provider, it's really difficult. So if the ownership belongs to JAXA, and if there is some sort of collaboration between your agency, I'm aware of there is a huge collaboration and cooperation between BRIN and JAXA. And so many researchers I know in Green now working with JAXA and taking the data for the research. So that would be one of the candidate framework that probably you can use.
Okay, yeah. Thank you.
Next question. Thank you, Mr. Ahmad. My name is Joko from Universitas 11 Maret. Yeah, actually, this work is very interesting for me. I mean, you perform in capacity building. Yeah, but I have some question about that. First, you are working for the data from the JAXA.
Mainly.
Yeah. For example, we have some data about problem in, for example, in remote sensing or something. Then we try to analyze what kind of materials and who are the candidate for the capacity building. Then we perform training, and then we also create the syllabus for the training, right? The problem is the data from the source, or for example, from Indonesia, which who will analyze this is for example, university in Indonesia will analyze, then collaborate with Restek. Then we propose that this is we want to create the capacity building for that. Can you explain? The step by step, if we have kind of some requirement or proposal, and how we can get the grant or the support from the RESTEC. Thank you.
Thank you so much. So from what I understand from the question would have two different part. The first part would be if there is any specific data requirement from the end user, whether we can design such kind of courses based on that specific data. This is the first part of the question. And the second part is if there is such kind of procedure, how would we go with that, right? So as for the first question, yes, there is such kind of framework with our capacity building. One of the example would be the example with the Vietnam Space Agency that I explained in the first case. So in the very beginning, in this year, we try to build up the fundamental of the remote sensing for our trainings. But in the next year, we basically use their own satellites observation, Sat information to work with. So that would be the data that they provide to us, and we develop the capacity building material and everything, and we have our course. That's the first part of the question, which is very much feasible. And I encourage you to, unfortunately, we couldn't have our chief manager for the capacity building today here, so he sent me. But I really encourage you, if there is any more question, please give us an email. He can probably explain the detail better than me. But for the second part of the question about the procedure, the procedure is a little bit complicated in terms of funding, because as I mentioned, we are not funding agency, so we cannot secure fund. But if you have already secure funding, we can play a role on that. For example, if there is between university and, for example, Sensei already mentioned before me, Chiba University and Indonesia University, there is some research collaboration with JSC, Japan Science and Technology Agency, or probably some funding from MIX. If there is some such kind of cases, you could easily request us to basically define the procedure for you, how to go with the proposal, writing the proposal to have us as your capacity building partner. But the main problem is for the funding part. Once the funding is secure from our end, it's pretty much straightforward. It's just quotation and everything. It's okay. Yeah. Thank you so much.
Okay, thank you very much, Dr. Pega. And due to our limited time, we need to end our discussion session. Thank you very much again for Dr. Pega, and give applause for Dr. Pega.
Thank you so much.
Yeah, ladies and gentlemen, we have finally come to the end part of this plenary talk of 18 International Conference on Space, Aeronautical, and Navigational Electronic ICSANE 2023. Before I close this session, please again give applause for all the speakers here, for you all. So see you all later, and thank you very much. I give back to Master of Ceremony. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you for the third keynote speaker, Dr. Pega Hashim Fathiabani. And then also, thank you for the moderator, Dr. Miftahul Anwar, for the third session.
And once again, thank you to all keynote speakers who conveyed knowledge which was certainly useful, and thank you also the moderator who led the plenary talk events. And we inform to all participants that you can have lunch on the 9th floor, and at 1:30 you can go to 5th floor to continue the next agenda, namely parallel session.
And now that we have finished this session for today, we would like to offer our sincere apology if there are any mispronounce of names, title of institutions that we accidentally have said. Thank you so much for ladies and gentlemen that have joining us until the last of the session. We appreciate for your activeness and also engagement to create better experience and memory from this ICSANE 2023 event.
And with that, we as master ceremony of this event, I'm Maulida Nabila Badria.
And I'm Fahrizal Ihsan.
We
We
are
are checking out and see you at gala dinner tonight. Wassalamualaikum warahmatullahi wabarakatuh.